Now we're going to look at one-to-one functions. Suppose we had this function f that consisted of the ordered pairs negative 2, 2, negative 2, 1, 0, 0, 1, 3, and 2, 5. We could put another set of ordered pairs from this one by just interchanging the x and y values. We're going to call this set G. So instead of negative 2, 2, we're going to have 2, negative 2. Instead of negative 1, 1, we're going to have 1, negative 1. 0, 0 looks the same. Instead of 1, 3, we're going to have 3, 1. Instead of 2, 5, 5, 2. This is another function. To show that these two sets are related, we call G the inverse of f. For a function to have an inverse, it must first be a one-to-one function. In a one-to-one function, for each x value that has only one y value, and each y value has only one x value. This function is not one-to-one because although these two domain values only have one range value, this range value has two of the same domain values. So this is not a one-to-one function. This would be one-to-one. Each single number in the domain corresponds with a single number in the range. This is a one-to-one function. Another thing that's true, if you have a one-to-one function and you have a and b that are in the domain of f, if a does not equal b, then f of a cannot equal f of b. Now that's a contrapositive from that statement, saying if the domain values are not equal, the range values cannot be equal. Then, contrapositive, we could say that if the two f of a and f of b are equal, that means a equals b. We can use this statement to decide whether or not a function is one-to-one in the next example. In this example, we have the function. We're going to show that f of a equals f of b leads to the result a equals b. Well, so let's do that. F of a would be negative 3a plus 7 equals negative 3b plus 7. So subtracting the 7 from each side, negative 3a equals negative 3b. Divide both sides by negative 3, a equals b. So it does lead to this. This function would be one-to-one. Now another way is we're going to start with two different values. A equals 3 and b equals negative 3. And we know that 3 does not equal negative 3. But what happens if, what about f of a? That's going to be the square root of 49 minus 3 squared, or the square root of 49 minus 9 is the square root of 40, or 2 times the square root of 10, 40 being 4 times 10. If I do f of b, the square root of 49 minus negative 3 squared is going to be the square root of 49 minus 9 again, the square root of 40, or 2 times the square root of 10. Here we have f of a equals f of b. But we already knew that a did not equal b. So this is not one-to-one. It's not one-to-one.